Okay, what I've done here, what I want to do now is to look at something further, and again a continuation of electrical principles. Okay, so Edexo National Certificate in Diploma Unit 5 Electrical and Electronic Principles, NQF Level 3. Outcome 4, alternating current. Now again, this guy Dunn has provided us with a lot of information that we can use. Okay, and he has given us examples that we can work through as well. So I'm not going to take too long on this overall, okay, because you will need to do some additional research, you will need to read the information, you will need to write it out and extract it and make it your own. There's no shortcuts to this. So with revision, basic theory, sinusoidal waveforms, okay, a pure alternating current of voltage varies with time sinusoidally as shown. Okay, that is your waveform. I'm not going to spend a lot of time talking on it. Okay, now here is the important part. Instantaneous values for sinusoidal voltage and current. Its instantaneous value at any moment in time is given by V equals V sine omega t and I equals I sine omega t, or V equals V sine 2 pi ft and I equals I sine 2 pi ft. Okay, it's just showing you here that the formulas, and these are the formulas you will need to apply and use. The amplitude, okay, here you should be able to read that for yourselves, okay, see that through. Frequency, periodic time, 1 Hz equals 1 cycle per second, okay. Angular frequency, now omega is the angle of the relevant, so in a three-phase system the angle would be 120 degrees out of phase with each other, so omega equals 2 pi f equals 2 pi f over t, or which brings it to rads per second. Now this is the gentleman here who has provided the information, okay, basically here. So in this case I've used a lot of his work already, but it has been quite useful and it's proven to be quite informative. Average values, okay, so all I'm going to do here now is just going so you can see the average values as they're specified, okay. Now these are for you to actually take down and draw out yourselves. I'm not going to try to read this to you, okay. Hopefully you can read this for yourselves, okay. Make sure I can go into this and you can bring it in close enough to be read. Okay. Form factor, peak value over average value, okay. And here you have phase displacement. The sinusoidal graph is produced because we made theta equals 0 when t equals 0. We could choose to make theta any value, so I call this theta, okay. Is how I remembered it myself in college, so for my own reference, okay. Now again here you can read this for yourselves. I'm not going to read this out to you, okay. This is a lot of work for you to read. Now again, pause the video, take the time to see what the information is saying and extract it and make it your own, okay. I've drawn these tables up myself as well in due course, okay. And here's some self-assessments for you to do. Now here he's giving you the answers, but what you need to do is to look at the calculation, because I can tell you this for no reason. Well, yes, for no reason, that some of these answers are not always correct, okay, and you have to calculate it, because there, because it's generated by machine, you get errors in some cases. Okay, it's not down to him. It's because he knows his stuff. Okay. Now, don't want to look at the answers before you've attempted the questions yourself. Okay, and again, here determine the following from the graph shown. Okay, and here is a good exercise. Now, these are good exercises for you to be working on. Okay, they are brilliant. I'm just going to go back to recap, okay, to make sure I get everything on screen, okay. Here we have root mean squared RMS values, okay, and again I'm going to step back so you can see what it's trying to say. Okay. Let me just move and make sure that you can read it, okay, and it's easy to read. Okay, let me go up now, okay, come back a bit. Okay. Now again, you need to write these out for yourselves. Make sure you understand the concept of it. And again, here he's giving you some examples, okay? Apply the calculation method being used, okay? You cannot go wrong. And again, thank you, Mr. DJ Dunn. And here you have other waveforms, okay? It's just moving that, make sure you can see them, okay? You know what they are. And again, here's your self-assessment, okay? Reactance and impedance, okay? Sorry about that. Now again here, let me just get back, move back a bit, make sure we can get this into view. Reactance and impedance, okay? Not much talking here for me to do. Again, you're dealing with capacitive reactance, XC, XL, etc. Okay, make sure you understand. Draw out the information, write out the examples, and here you have this work. Now, this knowing how to calculate this is important, because if you make an error in putting it into your calculator, you will make the answer will be incorrect. You must put in the process and use the correct formula for whether it is XC or XL. Inductive reactance XL. Okay. Again here, I'm not going to spend a lot of time on here talking to you. You will now need to do this for yourself, because you are the ones who have to do the calculations. I'm just providing you with the information by someone else who has put this in quite a informative manner, to which I found it to be quite useful. Okay, and I'm hoping that you will find it useful as well. Okay, and do the examples again. Do the examples. Let me just go back up a little bit, make sure that we can get it all in. Okay. do the examples. Now if you do these examples, you'll find that it will help you a great deal. Do the examples. And again, here you have your own self-assessment. From the information you've read, and I'm hoping that you can read it, I will check it before I post it. Okay. Okay. Phasor diagrams. Now again here. Now I've drawn this out previously, I think on one of the videos. I've drawn this out actually. So look back in one of the videos in the electrical principles section in the playlist, and you should find information showing you how to do this. Okay. You won't be able to click on these, of course, but you can use this information here to put it into your search engine, and you should be able to find that this will assist you as well. You can see the animations of this. It works. And again, here we are. Okay. And here we're simply adding vectors together. Okay. Now sometimes you have the vectors which will extend beyond that point there at a given angle. You then need to join your vector up from here to here. The central point will then become your value. Okay, basically. That's adding and subtracting phases. Okay, let's go back a little bit, make sure we can get it all in. Okay, yes, I think we can. Okay, and again here you have your word examples. Do the word examples, do the practice. Now the fact that it's been done does not mean to say that you don't need to do it. You will need to do it for yourselves, although it has already been done for you, right? So you can understand how it was done. One of the most annoying things I find is that you give them a work example and say, write out the work example and do this for me. Now you may change the value of the work example without they even knowing, yet unless they've done the example, they have no idea of the concept of actually doing the calculations, so they end up getting it wrong. Do the work example. Most irritating. And again, I'm not going to spend much time on this and saying this. Okay, this is again for you, for your own edification and your own working. Draw the diagrams. Now again here, this is capacitor with resistor in circuit, okay, and comply and apply the calculate, the rules and the formulas which is used to solve these problems. You cannot guess them. And this is an inductor in series with a resistor and capacitor. this work. Once you begin to master these calculations, you'll find that the rest of it becomes very easy. You can go on to level 4, level 5 without any problems, because you would have had the prior knowledge that you would need to work at that level. I'm just going back to recap. Okay, that's all I'm doing at the moment. Okay, that will be fair enough. Okay. Okay, I think that will be it for now. Okay, so I would like to thank you for your time, and again, I hope you found this useful. Okay, let me just go back a bit, make sure I can get everything into play. Okay. I'm just recapping now. Okay, making sure that it's visible and that I have been able to keep it in frame, all of it. Okay, thank you. Have a good day. Bye bye for now. Okay.